This part explains the single relation, the opening chapter installs beneath the entire book. Every substance is a poison, only the dose separates remedy from murder. Toxicity is a function of quantity, a matter of how much reaches the body rather than a fixed trait of the molecule itself. The historical suite confirms it. Aconite is a tonic in small doses and an assassin's tool in large, understood in China 2 millennia before the West named the law. What the chapter is for is planting the invariant that every later chapter varies. Dose response, target organ, and mechanism are all elaborations of one move. The adverse effect is a curve over exposure rather than a label stuck on a compound. History here is the slow, repeated rediscovery of that curve, culminating in Paracelsus giving it words. This section explains the single idea that organizes the whole chapter. Nothing is poison, only a dose is. The chapter's historical sweep, from antiquity's aerotoxins through Paracelsus to computational screening, is the slow discovery that toxicity is a relation rather than a property of matter. The predicate toxic never attaches to a substance. It attaches to the triple of substance, dose, and organism. Once you hold that, every distinction in the chapter falls out. Venom versus poison is just delivery mechanism. The word xenobiotic is the organism relative frame. Toxicodynamics and toxicokinetics are the two directions of the same interaction arrow. History here is not decoration. It is the record of a field converging on one relational axiom, the axiom that dissolves the folk category of the poisonous thing. This section explains the founding principle of toxicology, that toxicity lives in a relation rather than in a substance. Toxicity is a relation, the map from dose to response. Paracelsus gave the whole chapter in one line. The dose makes the poison. Every chemical injures above some quantity, and every poison spares below it. So the object of study is never the molecule, but the curve-binding exposure to effect. Fix that curve, and everything downstream falls out as a coordinate on it. Potency, safety margin, lethal fraction, the relational frame even predicts its own exceptions, where the curve is U-shaped rather than monotone, both deficiency and excess harm. An essential nutrient, or hormesis, is simply a dose. Response whose minimum sits off 0. This section explains the founding axiom of toxicology, the idea that turns it into a science. Paracelsus put it in one line: everything is poison, and only the dose fixes where on the curve you land. That line is the whole axiom of the chapter. Here is the move that makes toxicology a science rather than a catalog of dangerous substances. Toxicity stops being a property that a chemical simply has and becomes a relation between dose and response. Water and botulinum sit on the same axis. What separates them is 10 orders of magnitude in where their curves cross into harm, a difference of degree along a shared curves cross into harm, a difference in kind. So the object of study is a function. Dose maps to a graded or a quantal effect, and every idea downstream from it is just a coordinate read off that one curve, potency, threshold, therapeutic index, the LD50. Fix the relation, and the taxonomy of poisons dissolves. This section explains the single pipeline that every poison runs through, from first exposure to final outcome. Every poison, however many there are, runs the same 4 steps. A toxicant is delivered to a target. It reacts with a target molecule. That reaction provokes cellular dysfunction, and then the damage is either repaired, or, when repair itself misfires, it hardens into death, fibrosis, or cancer. The chapter's whole thesis is that mechanistic toxicology's endless catalog is this chain, and every named poison is just one path through it. Tetrodotoxin is the degenerate case. Delivery and reaction collapse into one direct sodium channel block, with no repair possible. So severity becomes a question of which step breaks, and whether the fourth step can catch it. The pipeline is the generative primitive. The poisons are its instances. This part explains why every poison follows the same path, and how that single path lets you predict any toxicant's mechanism. Every poison resolves to the same directed cascade: delivery to the target, reaction with a target molecule, cellular repair, adaptation, then failed repair. 4 stages in fixed order, shown in Figure 3.1. The step that does the work is this. Each stage carries its own break: pre-systemic elimination, detoxification, molecular and cellular rake. Pre-systemic elimination, detoxification, molecular, a cell, a last repair. So toxicity is a race. An adverse outcome appears only where forward flux outruns the opposing process at every gate. This is what makes the chapter generative, rather than a catalogue. Hand it any toxicant, and you predict its mechanism by locating which stage it enters and which break it overwhelms. The 1,000 mechanisms collapse to one pipeline with 4 failure points. This part explains why risk assessment splits toxicity from risk, and how the 4 steps compose into a single map. Toxicity is intrinsic to a substance. Risk is a property of an encounter. A poison that reaches no one harms no one. The whole architecture of the chapter is the map, carrying the first idea to the second. The National Research Council's Red Book, in 1983, factors that map into 4 composable steps. First, hazard identification. Can it harm? Second, dose response. How much harm per dose? Third, exposure assessment. How much reaches whom? Fourth, risk characterization. Which is their product? A probability of harm in a population. The move that does the real work here is institutional rather than scientific. It builds a firewall between assessment, which states only what the evidence supports, and management, which decides what to do. Facts and value. Judgments are quarantined, so each can be contested on its own terms. This part explains how toxicology turns into decision-making through a single factoring. Risk equals hazard times exposure, potency met by dose. That one product is the whole hinge. The chapter's entire apparatus is that product unpacked into estimable pieces. The National Research Council, in 1983, in what became known as the Red Book, set out 4 steps: hazard identification, dose response assessment, exposure assessment, and risk characterization. Each piece carries its own uncertainty forward, rather than collapsing to one falsely precise number. This is the book's hinge. Everything mechanistic, meaning what a molecule does to a target, is upstream input. Everything regulatory, meaning control, substitute, inform, is downstream output. Risk assessment is the composition between them. The generative move to keep is this. Hazard is intrinsic. Risk is hazard conditioned on exposure. No exposure, no risk, however toxic. This section explains how an external dose becomes the internal concentration. A poison actually delivers to its target. Toxicity is decided at the molecular target, what reaches it, at what concentration, for how long. Mere contact with the surface of the body does not settle the question. Absorption, distribution, and excretion are the 3 operators that transform an external dose into that internal profile of concentration versus time. Biotransformation, the fourth operator, is deferred to Chapter 6. Paracelsus, sharpened, reads this way. The dose that makes the poison is the delivered dose, the amount that actually reaches the target rather than the amount applied to the outside. The generative move is that every barrier crossed, every storage depot, every excretion route is one more filter on the same profile. So poor uptake or fast clearance renders a potent molecule harmless. And the depot of highest concentration need not be the target. DDT saturates fat without harming it. This section recasts the oldest rule in toxicology as a transport theorem. A poison has no toxicity of its own. It borrows toxicity from a rival. Paracelsus said, the dose makes the poison. The sharper statement is that the operative dose is the concentration that actually reaches the molecular target over time. The amount you are exposed to is a different quantity. Absorption, distribution, and excretion are the composed function that maps the first quantity to the second. Everything routes through one gate, passage across the lipid bilayer. So the whole apparatus is variations on a single move. Membrane crossing. The surprise sits in the anchors. The tissue that holds the highest concentration need not be the target at all. DDT sleeps harmlessly in fat, and deleting a single uptake transporter converts a liver poison into a bystander. Microcystin loses its bite once you remove the transporter, OP1B2. This part explains how the body eliminates foreign molecules and why elimination is really a problem of solubility. Elimination requires making a molecule the membrane rejects. That is the whole engine. A xenobiotic slips in precisely because it is lipophilic, with high passive permeability, and it would be endlessly reabsorbed in the kidney or the gut unless something inverts that property. Biotransformation is that inversion. It is an enzymatic operator that flips lipophilic and retained into hydrophilic and excreted. The generative move is this: solubility is the handle, and enzymes turn it. Dioxin fixes the boundary of this picture. Its halogenation obstructs the enzyme, not the membrane, so the flip never fires, and the molecule persists for years. And the flip alone is insufficient. A hydrophilic metabolite still needs a transporter to carry it out of the cell that made it. This section explains what decides how long a poison stays in the body and how the liver changes that. What sets a poison's residence time in the body is its permeability, not its toxicity. Biotransformation is the enzymatic knob that turns permeability down. Lipophilic molecules cross membranes freely, so the kidney and the gut reabsorb them endlessly. The liver's enzymes graft on polarity, converting them into hydrophilic metabolites that the plumbing can finally flush, with transporters shoving the products out. Here is the sting the chapter builds toward. The same machinery that detoxifies also bioactivates. Cytochrome P450 can manufacture the reactive species that does the damage. Metabolism is chemical re-engineering of escapability, indifferent to whether the product comes out safer or deadlier.